Hello, good day, everyone. Welcome back to another great section of this lovely tutorial class. Today, we'll be looking at solution to a series of problems in the limit problems, which is just the basis of differential calculus. And mainly, we are going to be looking at how to use L'Hospital rule to solve problems. Now, if you know you are not subscribed to this channel, please stay and do so. And if you know you have not watched our calculus videos, please try and watch them. We have so many videos under differentiation calculus. They are there: chain rule, product rule, implicit function, differentiation, and the rest. You can go and watch them. They are there. So today we are just going to be looking at problems under limits. And please don't skip any parts of this video. After everything, if there is anything you don't get, you are free to watch the video over and over again. And you can also drop your question in our comment section. Now let's move on to question 1. It said everything is to just solve, evaluate the problems. They said number 1, limit s approaches 2 of 8 minus 3x plus 12s squared. So we are going to limit this function now to x approaching 2. This is a polynomial function, we all know. So I told you guys in our first video that the first procedure and limit is to therefore impute these 2 into any place you are seeing x here. Just substitute 2 in where you are seeing s. Go substitute 2 to this place, substitute 2 to this place, you're going to have this. You're going to have 8 minus 3 times 2 plus 12 times 2 squared. I'll give you this. Then if you evaluate it, you're going to have 50. That will be the answer to this particular problem. So that's now number 2 is limiting this function 6 plus 4t over t squared plus 1 at t approaches minus 3. So the first procedure you do, or the first thing you do, anyway, see t, place minus 3 there. You're going to have 6 plus 4 times minus 3, then minus 3 squared plus 1. So before you put the square, ensure you bracket everything. So bracket the minus 3 because minus 3 squared is equals to 9. If this power is positive and you have a negative number and you are bracketing everything, and the power is not just positive, power is even number. If it's even number, this positive will change to, this negative sign will change to positive. That's what we do. So I've explained that before. We're doing complex number. If this power is it's an even number, this minus will change to plus. So this one is 2 now, even number. So if you find minus 3, everything square root, and take the square of it, you're going to have 9. Then plus 1. So if you solve this, you're going to have minus 6 over 10. So it has minus 3 over 5. This one is still correct. Now, anyone that is not correct is the one that will have 0 in the denominator. That is the one that will be wrong. So this one is still correct. And this is an answer, minus 3 over 5. Now let's, alright, question 3. Limiting the function s squared minus 25 all over s squared plus 2x minus 15 at s approaches minus 5. That's the question. The first thing, anyway, see s, put minus 5 here, minus 5 here, minus 5 here. We're going to have this. So minus 5 squared will give you 25 because 2 is an even number. The minus will change to plus. The same thing here. Then plus 2 times minus 5 will give you minus 10. That's what we're going to have. So this is minus 10. And if you solve this out, 25 minus 25 is 0. Then this minus this 0. Since there's 0 in the denominator, we cannot accept this answer. This is undefined. So let's solve this question in another form to check if we see an answer. So the direct option I'm unable to solve it because there's 0 in the denominator of the function. And anything over 0 is undefined. So let's use another method, which is L'Hospital method or the L'Hopital's rule. Using the L'Hospital or L'Hopital's rule of limit. Now, what is the meaning of this rule? I've explained this rule before in one of my videos, which states that if this direct method did not give us the actual solution to a limit problem, what we'll do, we divide both sides. We just then differentiate both sides, both the numerator and denominator, but with respect to this variable here, which is present in the question. So what we are going to do now, applying this rule means if this method failed to solve the problem, you differentiate this and this with respect to this x, which is here. So let's differentiate this numerator and denominator with respect to x, and so we are going to have. Now if I differentiate s squared, remember from our polynomial functions, to differentiate s squared, this is a polynomial function, we're going to have 2 times x, which is the power times the x, the power minus 1. Differentiate 2x, since this s is having the power of 1, the answer will be the coefficient, which is 2. Differentiate all these ones that don't have s to become 0, because they will become a constant, because they are not having this s we are differentiating with respect to. Now let's go see what I'm going to have. So differentiating the s square, I'm going to have 2x. Differentiating 25, there's no s there, 0. Differentiate this s square, we have 2x. Differentiate 2x, we are going to have 2, because the answer will just become the coefficient. Differentiate 15, 0, because there's no s there. So trying this, we are going to have this. Let's have it minus 5. Anyway, CS, put minus 5 there. You're going to have this. Then you have this. You have minus 18, minus 10 over 8. Minus will cancel minus. 2 into 10, 5. 2 into 8, 4. So we're going to have 5 over 4. Now let's move to the next question. Question 4. Question 4. Limiting 2z squared minus 17z plus 18 all over 8 minus z at s approaches 8. As z approaches what? 8. So the variable here now is z. Yeah. So this function is a function of z. So what I'm going to do, first of all, anywhere you see z, you put 8. If you will check now, if you put 8 here, it will be 8 minus 8, 0. So the thing will not work. See, 0 meter is going to give us 0 if you place 8 direct. So we are going to do now, I'm still going to use L2 rule here. Since the 0 meter is going to give us 0 by direct substitution. So you are going to differentiate both the upper side and the downside with respect to this z here. So now let's differentiate and see what we are going to have. Now, differentiating this numerator, we are going to have 2 times the coefficient, 2 minus 1. Remember, differentiating this 17z, it's just differentiate as if you are differentiating x. Just that it's almost the same thing. Differentiate z, since this z is not having, it's just having the power of 1, the z will go, only the 17 will be here. Then if you remember, if you differentiate as, the answer will be a. And something like that. So you're going to have 2 times z, 2 minus 1, then you have 4z. But 2 minus 1 is 1, that is z is power 1. 2 times 2 is 4. Then if you differentiate minus 17z, the answer will be minus 17. The z will go. Differentiate 8, it will be 0. So that is gone. Differentiate 8, 0. Minus. Differentiate z with respect to z. Since this and this are the same. If you differentiate this something with respect to the same thing. Differentiate s with respect to x, the answer will be 1. Differentiate z with respect to z, answer will be 1. Differentiate p with respect to p, answer will be 1. Differentiate theta with respect to theta, the answer will be 1. As far as both of them are the same thing, the answer will be 1. Differentiate this z and respect to z, the answer will be 1. There's no power, there's no coefficient, it's just z and z, exactly the same thing. The answer will be 1. So next thing, anywhere see z, you put 8. You put 8 here, you're going to have this. Then if you solve this out, you're going to have 15 over minus 1, which is minus 15. Now, let's move to the next question, which is question 5. Limiting y squared minus 4y minus 21 over 3y squared minus 17y minus 28 at y approaches 7. So if you place the value of 7 to any place you are the place you are seeing y here, you're going to have 0 over 0 as your answer, which will not work. That's why I'm putting bad. That means we have 0 in the denominator. That is not going to give us a valid solution. So next thing, let's differentiate both sides using the L2 rule. Differentiating y squared, we're going to have 2y. Remember, 2 times y, 2 minus 1, or 2y. Differentiating 4y, the answer will be 4, since this y is having the power of 1. Differentiating 21, there's no y here, 0. Differentiating 3y squared, we're going to have 2 times 3, 2 minus 1, that is 6y. Minus differentiating 17y, the answer will be 17, which is the coefficient of the y. Differentiating 28, there's no y here, 0. Next, anyway you see y, you put 7, 7. Then we're going to have this. If you try this, you're going to have 2 over 5. That will be the answer to the problem. So the answer to this problem now is 2 over 5. Now let's move to question 6. Now, question 6. Limiting the function bracket 6 plus h squared minus 36 over h at h approaches 0. let's see how to do this one now to see what we're going to have. So you have to pay attention now because we are already going towards techniques of differentiation. So this one now is not straightforward, so you have to be attentive so that you understand the explanation to this. So the first thing, anywhere you see h, you are going to put 0. So you put 0 here. We have 6 plus 0, 0. 6 squared 36, 36 minus 36, 0. Put 0 here, 0. We have 0 over 0. There's no, we don't supposed to have 0 in the denominator. So that's not working. So we have to bad this. It's bad. It's very, very bad. The next thing, we are going to differentiate both the upper side and the downside now to see what we are going to have. Let's differentiate to see what we are going to have. Now, how will we differentiate something like this? Let's say you have bracket, a function inside is carrying 2 as power. Look how to differentiate it. How to do it. The first thing you do, you pick this 2, which is the power. Write it down. Then differentiate inside the bracket. Differentiate is 0. Differentiate h with respect to h1. I already explained that. If both of them are exactly the same thing, you'll be 1. Differentiate c, there's no h here, 0. Differentiate this one will be 1. So 1 plus 0, 1. So you use 1 to multiply. When you differentiate inside this place, you're going to have 2 times 1. Then repeat this thing back. Repeat the same question back and remove 1 from the power. You're going to have this. Differentiate 36, 0. Differentiate h with respect to h, 1. So that's all. That's all. So it's a very simple thing to do. So next thing, if you multiply, we are going to have 2 times 1, that's 2. Bracket 6 plus h, 2 minus 1, that's 1. Divided by 1, the same thing. Anywhere see h, put 0, putting 0 here, we're going to have this. 0 plus 6, that is 6. 6 times 2, 12. The answer becomes 12. Now, another question, question 7. This another one. You need to be very attentive. Very, very, very attentive. Because we have a way of solving this problem. Now, we can also solve these problems, use factorization method, or you can also solve rationalization method. See, this one is involving sort. But I'm using L hospital rule throughout because I love L hospital rule. So the next thing we're going to do now, the first thing, let's place 4. Anyway, we say limiting root z minus 2 all over z minus 4 at z approaches 4, getting closer to 4. So first thing, okay, let's assume z is 4. Put 4 here. Well, we are square root of 4. 2 minus 2, 0. 4 minus 4, 0. So we're going to have 0 over 0, which is not a valid solution. So what are we now going to do? We're going to differentiate both sides with respect to z. Now, how will you differentiate root z? How will you differentiate root z? Look how to do it. Be attentive. That's the first thing. If I want to differentiate square root of a function, the root of a function, this is a function of z. It's a function of z. We have a function of z here. When we say root of a function, what you do? You want to differentiate inside the root. Differentiate what is inside this root now? Z. Differentiate this z, you will have 1. You write it down. Then divide that answer by 2 times the question itself, which is this root z. That will be the answer. It looks like a magic, Abi? It looks like a magic because I'm just teaching you how to do something like shortcut, how to cut something short. So this actually, if you want to solve this one, use chain rule. But there's no, because the thing will be too long if you're using chain rule. So I'm just giving you the shortcut to this. Differentiate inside this root now. You're going to have 1 over, then divide that answer you're going to get by this same question multiplied by 2. That's why we're going to have 2 times z. That is the mood there. I think we have a video class on this, how to differentiate the square root of a function, which is chain rule 2. I repeat, to differentiate the root of a function, what you do, differentiate what you have inside the root. You're having 1, and divide that answer by 2 times the question you are differentiating, which is the question itself, is 2 times the root. This 2 is from the formula. This 2 is not from the question. I repeat, you have root of a function. I want to differentiate it. Differentiate inside the root, write the answer down, and divide the answer by 2 times the question. As here, you can hear minus differentiating 2, 0. Differentiate z relative to z, 1. Differentiating 4, you're going to have 0. Next, this minus 0, we're going to have this. Divided by 1, the same thing. So that's why we're just having only this. Minus 0 divided by 1 will still be this. Next, anyway, see, we put 4. We're going to have 2 times root 4. Root 4 is 2. 2 times 2, we are going to have 4. That's 1 over 4 answer. That becomes the final answer. Now let's go to the last question. The last question. Please try and be following. Alright, lastly, which is question 8. Limiting the function root of 2s plus 22 minus 4 over s plus 3 at s approaches minus 3. What are we going to have? Let's see what we are going to have. Now, the first thing, anyway, see s, put minus 3. We're going to have 2 times minus 3. That is minus 6 plus 22, 16. Root 16 will be equal to 4. 4 minus 4 is 0. Minus 3 plus 3, 0. We are going to be having 0 over 0 if you impute the values directly. So this is not correct. That will be bad. The next thing, differentiating both sides. Go to differentiate both sides. Remember I told you how to differentiate the root of a function. You have the square root of a function. The square root, not any root, not cube root, not fourth root. It must be square root. That's why you are going to do it using this my method or this shortcut. So for square root of a function, what you do, you first of all differentiate inside the function. Write the answer down and divide the answer by 2 times the question. I've already explained that. So you're going to have differentiating 2, you have differentiating 2s, you're going to have 2. Differentiating 22, we're going to have 0. 2 plus 0, we're going to have 2. So that's why I was writing 2 here. So if you differentiate inside this place now, we're going to have 2. Then after you have differentiated that function, the next thing you do, you will divide the answer you're going to get from this function by 2 times this full question. That's how to do it. Differentiate this side, this root, we're going to have 2. Then divide that 2 by 2 times this question, we're going to have this. Minus differentiating 4, 0. Differentiating s, you're going to have 1. Differentiating 3, 0, because this and this, they don't have x. There's no s here, there's no s here. They're dependent variable, which is a constant. They are just constant number, this 4 and this 3. The next thing, this minus 0, that is this 1 plus 0, 1 divided by 1 will still remain the same thing. So we're having, now, listen, 2 cancel 2, we have 1. Yes, we'll now be having 1 over root 2s plus 22. They're divided by, now, we'll be having limit 1 over root 2s plus 32. That's average 23 minus 3. At average minus 3. Anyway, CS put minus 3. Put minus 3 here. 2 times minus 3. That is minus 6 plus this. We're going to have 16. Now, what is the square root of 16? That is 4. We're going to have 1 over 4. That's our answer. So please ensure you grab especially the shortcut I did. Very, very important in calculus. Very, very important. Very, very important. So you just a techniques which we call chain rule, and I just shorten it by some math tricks. So please follow us up in this channel. We should be give you guys more updates, and as far as mathematics, physics, and chemistry is concerned. So God bless you. See you guys in our next class. Thank you.